Hi everyone, this is the 159th video of the ACT Math Practice Problem series, and here we have an interesting problem from coordinate geometry. As I always recommend, before seeing the solution, you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says the coordinates of 3 points are A 2, -2, B 5, 1 and C 2, 4. If the points are joined by straight lines, they would form which of the following 5 geometrical shapes? To solve this type of problem, the first thing we should do is we should try to find out the length of the line segments. Like for example, what is the length of the line segment AB, and then what is the length of the line segment BC, and then AC. So let's first try to find out the length of the line segment AB. That would be square root of 5 minus 2 whole square plus 1 minus -2 whole square, and that would be equal to square root of, this is 3 squared, that is 9, plus the other one is also 1 minus -2, that is 1 plus 2, that's 3 squared, that is again 9. So this is actually square root of 18, and I'm going to keep it as square root of 18, and later on if we need to we can express it as 3 times square root of 2. Similarly, let's try to find out the length of BC. That will be equal to square root of 2 minus 5 whole squared. 2 is right here, 2 minus 5 whole square plus 4 minus 1 whole square, and that will be equal to square root of, this is 2 minus 5, that's -3 whole square, that is 9, plus 4 minus 1, that's 3 whole square again, that is 9. So this is again square root of 18, and that can also be written as 3 times square root of 2. And how about the line segment AC? Well, AC would be equal to square root of 2 minus 2 whole square plus 4 minus -2 whole square, and that is equal to square root of 2 minus 2, 0, that's 0 square, plus 4 minus -2, that's actually 4 plus 2, that is 6 squared, and that is equal to square root of 36, which can also be written as just 6. So now let's see if these line segments are equal. If they are equal, then it could form an equilateral triangle. But as you can see, the line segments are not of equal length. Okay, now let's try the right triangle condition. Now, do we have AB squared plus BC squared equals AC squared? And looks like it is. So if we say here, what is AB squared then? Well, we can say AB squared is equal to 18, and BC squared is also equal to 18, and AC squared is equal to 36. And now if you see, we can say then AB squared plus BC squared is equal to 18 plus 18 is equal to 36, which is equal to AC squared. So we can clearly see that AB squared plus BC squared is equal to AC squared. That means they could form a right triangle like this, and also we can say AB is equal to BC. So these two sides are of equal length, and the lengths are such that it follows the Pythagorean theorem, AB squared plus BC squared equals AC squared. So AC looks like the hypotenuse, and then this must be the right angle right here. Angle ABC would be the right angle. So then we can clearly see that this is going to form a right triangle, and also the two non-hypotenuse sides are of equal length. So then clearly we can see that when we join the 3 points, it's going to form an isosceles right triangle, because we have two equal sides and also it is a right triangle. So then our correct answer would be option E, which is an isosceles right triangle. If the lengths were all equal, then it could have formed an equilateral triangle. If the lengths were all different and follow the triangle inequality, then it could have formed a scalene triangle. Now, if the points were all collinear, then we could have found something like this. We could have had maybe AB plus BC equals AC, or maybe BC plus AC equals AB, or maybe AB plus AC equals BC. If you see that kind of a pattern, then you know that the points are all collinear. So for this type of problem, it's always a good idea to find out the length of the line segments, and from there you can draw a lot of conclusions. And to solve this problem, the only theory that I used was the distance formula, which says distance equals distance between 2 points, obviously, that is equal to square root of x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared. That is the distance formula, and that's what I used. And the only other concept I used was the Pythagorean theorem, where we say AB square plus BC square is equal to AC square. So those are the only two theoretical concepts have been used to solve this problem. I hope everything made sense. Thank you for watching. See you in the next video.